Hello, class. Today we're going to take a look at 3.6, which is all about multiplying polynomials. Now, earlier in this unit, we talked about multiplying monomials, single terms, with a polynomial. Now we're going to talk about multiplying larger polynomials with other larger polynomials. So possibly binomial by binomial, possibly binomial by trinomial. That's what our goal for today is. Now, we've already done the activity leading up to this, so we kind of have a sense of how to do this with algebra tiles. But before we start reminding ourselves about those algebra tiles, let's just talk about simple multiplication, the multiplication that we've been doing all this time. So let's start off with this question. Pause it, quick, do that multiplication, see what you get. All right, now we're back. So I go 7 times 5, well, that's 35. And then I do the 7 by the 1, and I get 7, and I add the 3 to give me 10. Notice I did this multiplication, 7 in the 5 in the 1's place, and 7 with the 1 that's in that 10's place to get me that 105. Now, in my next line, I'm going to have that placeholder 0 because now I'm multiplying this 1 in the 10's place by the 5, which gives me a 5. And the 1 in the 10's place by this other 1 in the 10's place, which gives me a 1. Now, of course, I add up all of these products, and I get 255. Now, why did I really walk us through what 4 multiplications were happening there? Is because we can show those 4 multiplications in a different way using grid method. Now, we talked about grid method for multiplication at the beginning of the year when we were doing some review. So instead of 15 by 17, I could write 10 and positive 5 because that's the same as 15. And I could just say the same as 17 is 10 plus 7. Now, if I'm using grid method here, I'm going to have these 4 multiplications here after my setup. I know that 10 times 10 is 100. Moving across in this direction, 10 times 5 is 50. 10 times 7, 70. And 7 times 5 is 35. Now these 4 products, I'm now going to add them together. 100 plus 50 plus 70 plus 35. And I get the same thing. 150 give me 150. 70 and 35 give me 105. And I get 255 as an answer. Hey, that's the same thing as we did here. We'll notice that in this bottom row, this is where I did the 7 by the 5 to get that 35, and the 7 by the 10 to get 70, and I added this 3 there. So really, grid method and the multiplication that we're used to are the same thing, just shown a little bit differently. Of course, we know they're the same thing because they get the same answer. Now, similar to how there's different ways to multiply actual numbers, there's different ways to multiply polynomials. The key thing here is that they're all the same method. They're all the distributive property shown in different ways. So algebra tiles, grid method, rainbow, those are just some of the different ways we talked about how to represent my multiplication. So, if I'm taking a look at algebra tiles, I kind of start off with my T-chart. And I have these 2 values as my dimensions. And it doesn't matter which side I put them on. I'm going to put X and then plus 1 on my left-hand side there. And I'm going to put my X and my minus 3 along the top. And now, of course, with algebra tiles, I don't write X and minus 3 and the X plus 1. I actually draw those tiles. So here's my X, and here's my 3 that I replaced the top for. Now it is a minus 3, so I am going to shade those all in. And then I'm going to have my X plus 1 along the side. All of those are positive, so I've got that there. With algebra tiles, I go ahead and I draw my grid lines between all of my tiles. Gives me an easier way to figure out what goes in those spots. Of course, I know that in here I have an x dimension on the left and an x dimension on the right, which of course gives me this x squared tile, but also that tile just happens to fit beautifully in there. Now, I'm not going to worry about all of my positives or negatives quite yet. I personally like to do those at the end. So that's what I'm going to do. Now I filled in all my tiles. Now, of course, I need to check about my negatives. When I'm talking about this tile, that was a positive times a positive, so it'll remain positive. This is a positive times a negative. This is a positive times a negative. This is a positive times a negative. So all three of those vertical x tiles will end up getting shaded because they all end up being negative. This is a positive times a positive. It stays unshaded. These three are all positive times negatives, so they'll all be shaded in. Now, of course, when I take a look at this here, my answer to the multiplication question is this. It is not the things outside my t-chart. It is just what I created using that t-chart, acknowledging those zero pairs and placing things in standard form. I get x squared minus 2x minus 3. That's my final answer. All right. We can do the same thing using grid method. And I almost accidentally set up the algebra tiles in grid method by mistake. I wrote x and the minus 3 at first. And that was actually a little bit better of preparation for grid method than algebra tile method, but that's okay. So I have x plus 1 going down. I draw in those grid lines the same. So very, very similar, except instead of drawing the tiles, I'm just writing the term that represents those tiles. And then I do the multiplication. In here, x times x gives me x squared. Here, x times negative 3 gives me negative 3x. Here, 1 times x will give me 1x, or just x. Because it's not my final answer, I'm okay to include that coefficient. And 1 times negative 3 will give me negative 3. Now, the nice thing about grid method is when I'm looking at my like terms most frequently line up on my diagonal there. So when I'm going ahead and writing out my final answer, I'm really adding all those boxes together, but acknowledging any like terms or zero pairs that exist. I get my x squared minus 2x minus 3. Now, of course, I'm not very surprised that these end up being the exact same thing, because they're just two different methods. And I'll notice that this x squared and this x squared, this negative 3x, this negative 3x, the positive x, and the negative 3 and the negative 3 end up actually being in the same spots because they're just different representations of the exact same thing. All right, last but not least, rainbow method here. So when I take a look at rainbow method, I'm going to write out my original question, x plus 1, x minus 3. Now, rainbow method, I still need all four of those multiplications to happen. I'll notice that here, this x, my x plus 1, ended up multiplying by my x and my negative 3. So it gets distributed to everything in that second set of brackets. So x times x gives me x squared. X times negative 3 gives me negative 3x. Now, of course, the plus 1 in my first bracket also distributed to every single thing in my second bracket as well. So 1 times x gives me 1x, and 1 times negative 3 gives me negative 3. And of course, when I collect my like terms, I get x squared minus 2x minus 3. Now, all three of these things, exact same skills, different representations of it, right? And we can see the similarities, right? There's an x squared here. We have the negative 3x. We have the positive 1x. And we have the negative 3. So if I color code them, hopefully we can see the similarities in all four methods. Now, algebra tiles, kind of like before, only really work if we have those smaller degree terms. So if we just have like a single x in a bracket, that's going to work out just fine because x can be used to represent a dimension. But if I have x squareds in some of my brackets, I'm not going to be able to use the algebra tiles method. Grid and rainbow work all of the time. Personally, I like using grid when I have, let's say, two larger termed polynomials multiply together. I really like how it helps with my organization. Rainbow method I like to use for those kind of smaller ones, like two binomials or a binomial and a trinomial. Just my own personal preference. And you could have your own preference too. Now, just to tie things back full circle here, numbers we're able to multiply this way. Technically, you could do the same thing with polynomials. In our numbers, we took our bottom right digit and multiplied it by everything at the top. We're going to do the same thing, except we're going to take the bottom right term and multiply it by everything at the top. So -3 times +1 gives me -3. And then I'm going to do the same thing. -3 times x gives me -3x. Just as before, when I was doing my second digit in my bottom row there, I had to have a placeholder. So I'm going to do the same thing. And now I'm going to take this other term and multiply it by everything at that top as well. So x times 1 gives me 1x. And then x times x gives me x squared. Now you'll notice that the way I'm doing this, all my terms, because of that placeholder, end up being in these columns here. And what do we do when we multiply numbers? Well, we add both of those two kind of rows together. So I have -3, I have -2x, and I have x squared. So I do end up with the same thing. Is this a common method? Not so much, but can you see that it still works? Hopefully, yes. Okay. Now let's get to the good stuff. So let's talk about something I can't use algebra tiles with. And again, I can't use algebra tiles here because I have an x squared. X squared with algebra tiles does not represent a dimension. It represents an area. And I can't use that in algebra tiles. So grid method and rainbow are my options. So I'm going to set up my grid method. I'm going to put my x minus 3 along my left side there. So x minus 3. And I'm going to put x squared plus 6x minus 5 along the top. Now pause this question. Try it on your own. See if we get the same thing. All right, welcome back. I'm drawing in my grid lines here. So in between every single term going down and between every single term going across. Now, because I have a binomial times a trinomial, now I have 6 multiplications I have to do. And that's totally fine. In my top left row, I get x cubed. Moving to the right, I get 6x squared and -5x. Now the bottom row, starting from left to right, I get -3x squared. I get -18x, and I get +15. Now, something kind of cool about grid method, like I said before, is that usually your like terms are along those diagonals. Not always, depending on what you have in terms of your polynomials to begin with, but usually they do. And if they do, it's a good way to double check that if you're on the right track. So if this was like an x to the 5, I wouldn't automatically say that it's wrong, but I would double check it to make sure that I'm actually doing things correctly, because I would note that as a little irregular. Now, of course, I'm going to represent my final answer below. I'm going to collect my like terms. So x cubed, standard form, I make sure I do that one first. My x squareds go second, and I'm left with 3x squareds once I cancel out those 0 pairs. -5x and -18x, well, that's just -23x. I have 23 negative x tiles there. And then I have +15 at the end. I'm going to do the exact same thing with the rainbow method. Pause the question. See if you can do it on your own. And welcome back. So here I have x minus 3. I have x squared plus 6x minus 5. Now this x in my first bracket has to travel and reach with every single term in that second bracket. So when I distribute that x, I get x cubed, I get 6x squared, and I get negative 5x. Now, of course, I might have run out of room here. I'm going to shift things over just a little bit. Of course, that negative 3 also needs to distribute to everything in that second bracket. So negative 3 being distributed to the x squared gives me negative 3x squared, negative 18x, and positive 15. Now, when I go ahead and take a look at my like terms aren't in like a beautiful order here. They are kind of scattered about, but that's okay. I can still recognize them. And I will go ahead and collect those like terms. My x cubed will be first, standard form-wise. My positive 3x squared will be second. My negative 23x will be third. And my positive 15 will be last. Now, if you look at these two, you'll notice exact same terms, exact same values, just represented in a slightly different way. All right, let's talk about the F word, and it's not the one you're thinking of. In math, we don't like teaching tricks because sometimes students will take tricks and they'll go, I don't totally have to understand it, that's okay, I'm just going to use this trick forever. And then realize, oh crap, this trick doesn't always work. I mean, it works most of the time, maybe, or maybe even some of the time, but it doesn't work all of the time. Now, FOIL is the specific F word I'm talking about here because it is a common trick you'll hear to help remember people how to multiply two binomials. So this works when I have two-term polynomials being multiplied by each other, but it does not work if I have a binomial by a trinomial or two trinomials together like we did in this last example. FOIL would not work here because we don't have two binomials. FOIL would work here because I do have two binomials. Now let's talk about what FOIL means. FOIL is just an acronym that helps me remember all of those distributions. So we talked about x having to be distributed to every single term in the second bracket, and we talked about this 9 having to be distributed to every single term in the second bracket as well. That's what FOIL tells us. We're doing the same thing, except we have names for them. So F stands for first, so it's the first term in each of the two brackets that multiply together. So this first term x and this first term x multiply together. The next multiplication are the outside. So the x is on the outside of that bracket and the 1 is on the outside of the bracket. So that's my outside. My inside terms are this positive 9 and this x they multiply. And my last terms in each of those two brackets, which are the positive 9 and the positive 1. So it's just a quick shorthand way to help remember, but it only works if we have two binomials. However, grid and rainbow method, not tricks, methods, because they'll work every single time for every single multiplication. Okay, now before we get going for this next 6 examples that we have, we are going to tackle these questions. I'm going to go grid, rainbow, grid, rainbow, grid, rainbow. Now, when we go ahead and do this, I really want to make sure that you try the different methods so you know how they work and understand those things. Now, what I want you to do is I want you to pause the video, do as many questions as you can, and then come back once you're done, and I'm going to walk through it a little bit quickly, but walk through it to make sure you're on the right track. All right. Welcome back. We are going to start this first one with grid method. I'm going to draw my t-chart here, and along the left-hand side, I'll put that first polynomial, 2x plus 1. Along the top, I'll put the second polynomial, x plus 2. I, of course, draw my grid lines here. Oops. And I'm able to do the multiplication. Going at the top left corner and working my way across, I have 2x times x giving me 2x squared. I have 2x times 2 giving me 4x. I have 1 times x giving me x. or 1x, and I have 1 times 2 giving me 2. Now, of course, this is not my final answer. Oops, that's not a highlighter. I need to collect my like terms and write my answer as a simplified algebraic expression. So I get 2x squared because that comes first in standard form. I collect my like terms of 1x and 4x and I add them together to get 5x. And I, of course, have my plus 2. Things that are important. If you do not show this step, you did not answer the full question in the way that we want you to. It is not just enough to draw the grid. You do need to simplify it as well. If you need to look through this question, you're copying things down, please pause the video. Make sure that you do so. But I'm going to keep on rolling here. All right, rainbow method. So I'm not going to rewrite this here, but I am going to distribute the A to every single thing in the second brackets. Because this is 2 binomials multiplying together, I could think of it as FOIL. But I don't like thinking about FOIL too often because if I can just think about distributing into every single term in my second bracket, I know it's going to work all of the time. So A going to that 2A gives me 2A squared. That A going to the 1 gives me 1A. Of course, that 3 also wants to be distributed, so that 3 going to the 2A gives me 6A. And the 3 going to the 1 gives me 3. I will collect any like terms that I have, which happen to be in the middle there. Standard form tells me 2A squared goes first, 7A goes second, and plus 3 go last. Again, like I said, pause the question, pause the video if you want to take a look and copy things down or you need to have a moment. But I'm going to keep on moving on. All right. Taking a look at C here, grid method. I'm going to make my T-chart. I'm going to put x plus 1 along the left-hand side. And I'm going to put 3x squared minus x plus 2 along the top. Now this I cannot think of FOIL for. This I also can't use algebra tiles for. So grid method and rainbow will always work. Now moving from top left corner across the row to the next, I get x times 3x squared giving me 3x cubed. Now I have a positive x times a negative x. So that'll give me a negative, and x times x gives me x squared. X times 2 gives me 2x. Next row here, I have 1 times 3x squared. I know that multiplying anything by 1 will get me the exact same answer. So that whole row will stay the same as that top original row because 1 doesn't change anything. Now again, looking for those like terms, I'm looking at those diagonals and that's where they happen to be found. And I'm of course going to simplify as I go. So I get 3x cubed all on its lonesome. I get 3x squared minus, and I remember there's like a secret 1 there, minus 1x squared, giving me 2x squared. Again, I could draw on those secret 1s as long as it's not in my final answer. So 2x and negative 1x give me just 1x, which is just written as x if it's my final answer, and plus 2. Alrighty, moving on to the next one, rainbow method. Again, I can't think of FOIL here because I've got a binomial times a trinomial. So let's start with those distributions. A gets going to every single thing in that second bracket. So A with 3A squared gives me 3A cubed. Ooh, I've got A's and B's here. Just a reminder, when I'm going ahead and distributing that A, I could pretend there's that coefficient of 1 there. I go number by number. So 1 times 2 gives me 2. I could also write in my secret exponents there if that's going to help me, because A times A will give me A squared. And B has nothing to multiply with, so it just tags along. Now for that last one, I have 1 times that negative 1, so I'm going to end up with a negative 1 here. A has nothing to multiply with, so it just stays as an A. And B squared has nothing to multiply with, so it stays as a B squared. All right, now that negative 5b also multiplies by everything in the second bracket. So I go negative 5 times positive 3 gives me negative 15. I go alphabetically, so a squared has nothing to multiply with. It stays there. B has nothing to multiply with, so it stays there as well. Negative 5 and 2 give me negative 10. A has nothing to multiply with, so it stays as an A. B and B could multiply to give me B squared. All right, last term, negative 5 and negative 1 give me a positive 5. B times B squared give me a B cubed. All right, now when we take a look at this one's a little bit tricky because there's two variables going on, but I'm just going to look at any like terms I might have. So there's only one term with an A cubed. This, I need another term with an A squared B. And this negative 15A squared B will do the trick. Here I have something with a negative 1AB squared, so I'm looking for another term with an AB squared. And this negative 10AB squared does the trick. And I get 5B cubed at the end. Now don't forget when we're collecting like terms that the sign that comes ahead of it is part of that collection. So I don't really have to worry about standard form or how I order my final answer. I'm just going to work from left to right. So the yellows first, I'll go 3A cubed. Then I'll go my purples, so 2 and negative 15. Oops, that should be negative 13A squared B. The negative 1 and the negative 10 will give me a negative 11AB squared. And then, of course, I have 5B cubed. Now, just a reminder why I don't really mind how it's written in standard form here is because there are two variables in a single term, and we talked about that being a little bit too complex for what we're at in grade 9. So any order that you have your final answer in for this particular question will be A-okay. All right, we've got two examples left. Now this one brings us back to exponent laws here, and very, very important to remember, exponent laws only apply to multiplication or division. They do not apply to addition or subtraction, which means we cannot distribute this. This is a big no-no. However, we know more than just exponent laws. We know how to write exponents instead as repeated multiplication. And repeated multiplication for exponents, well, this just says that the 2 applies to the bracket. It applies to the whole entire bracket, which means in repeated multiplication, that whole entire bracket repeats. Well, now I can easily do this as grid method if I wanted to, because that's just an x plus 4 on the top and an x plus 4 on the side, and I can tackle this no problemo. Like I said, if you want to try this question on your own, please feel free. I'm going to continue doing the rest pretty together here. So if you want to give it a try, or if I'm going too fast for you to go on the next one, pause it at any point. All right, top left corner, x times x gives me x squared. Moving to the right, x times 4 gives me 4x. Bottom row, 4 times x gives me 4x, and 4 times 4 gives me 16. I'm looking for any like terms, and those happen to be found along the diagonal here as well. So my final answer after collecting the like terms should be x squared plus 8x plus 16. So being very, very careful here, that is probably the biggest common mistake that grade 9s make. And honestly, even some kids in grade 10, is that we get so caught up to the joy of exponent laws that we forget that exponent laws do not apply to addition subtraction. So we accidentally do it and we go, that's just x squared plus 16, which we could see now is quite different than x squared plus 8x plus 16. Right? We have different tiles, we have different terms. So be careful. Okay, the last one. All right, the last question has more than one multiplication statement going on. So real quick here, let's talk about what would happen if we were multiplying, more than 2 numbers. So let's say I had 3 times 4 times 2. Ooh, I've got hiccups all of a sudden. Okay, if I did that, I'd have to multiply these 2 numbers at a time and then multiply my answer by the third number. So what I mean by that is we would usually do something like this. We'd go 3 times 4 is 12. And take that answer as 12 times 2. Well, that's 24. Now, I want to talk about this middle step here. This middle step, highlighter, here we go. This middle step, I can write as 12 times 2. We know that. It's the same thing. But what if I didn't have 12 as a single number? Let's say I had 12 as like something in brackets here. 11 plus 1. Now, those brackets are super duper necessary because BEDMAS tells me that if I know those numbers, I would have to simplify them first before multiplying. Now, when we do things like multiplication with polynomials, it's not always possible to simplify what's in our brackets here. So the 5x and the 1, we don't know how to simplify because those aren't like terms. Same thing, x and the minus 3, we don't know how to simplify because they're not like terms. So when we're doing this multiplication with our polynomials, when we multiply these numbers, we get a picture of these numbers having brackets around them to start instead. Now, as long as there is more multiplication that needs to be done, we will continue our steps in brackets until there is no distribution left. So that will ensure that we make sure we get all of the multiplication done correctly and we're not accidentally missing out any important chunks. So that's what we'll do. All right, let's make this small and off to the side. Oop, there we go. So just like the first two numbers being multiplied, I'd multiply 2 at a time and then take that answer and multiply by the third number. I'm going to do the same thing with the polynomials. I'm going to multiply the first two polynomials, this monomial of 3 and this binomial of 5x plus 1 together, and take their product and then multiply it by that third polynomial. All right, when I do that multiplication, that's just me distributing the 3 to every term in that bracket. 3 times 5x gives me 15x. 3 times 1 gives me 3. And I'm remembering to keep that answer in brackets because there is still more distribution to do. So this guy just got copied down because I did nothing to him, just like I did nothing to this 2 here. But the key thing is that 12 stays in brackets because there's more multiplication going on. Just like this will stay in brackets because there's more multiplication going on. All right. Continuing on with those multiplications. 15x gets distributed to everything in the second bracket, and so does that positive 3. When I do those green distributions, I get 15x squared, and I get negative 45x. When I do those positively purple distributions, I get positive 3x and negative 9. And of course, I'm looking for any like terms as I go because my final answer is not simplified until my collection of like terms is all over. So I got my x squared in yellow, I got my x's in purples, and I got just my numbers in blue. I'm going to collect them. Standard form suggests that my 15x squared goes first. My negative 45 and positive 3 result in a negative 42x. And the negative 9's on its lonesome there, nothing to collect with. But this is, in fact, my final answer. All right, we have completed the notes. There is practice that follows. Otherwise, that's it. I hope you have a lovely day. Toodaloo.